Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Chapter some basic principles and techniques in organic chemistry, and we are doing the topic types of reaction. Hello friends, in the last lecture we have studied about what is reagent, and that is electrophilic reagent and nucleophilic reagent. And based on that only we are going to discuss about, we know that a substrate has been reacted with the reagents, and because of that only we could get a product. So based on that only we are going to discuss what are the types of reaction that we could observe in organic reaction. So let us talk about it. So as mentioned on your screen, there are types of the reaction that we are going to discuss about, and basically in organic reaction there are usually 5 types of reaction that we are going to talk about, and those are, starting with the first one, that is substitution reaction. The next is addition reaction. After that it is elimination reaction, rearrangement reaction, and condensation reaction. So these are the 5 major types of reaction that we are going to talk about, and based on that we are going to discuss about the examples also, or the chemical reactions. So let us talk about each of the reaction by learning what is the definition of it, or what is the meaning of it, and we'll do, that is, a reaction on that. So let us do it. So starting with the first one, that is substitution reaction. So a reaction in which an attacking species, that is electrophile, nucleophile or free radical, directly replaces an atom or group of atoms in the substrate is called as substitution reaction. So what does this mean? Let me give you with an example. Suppose if we have a reactant or we have a substrate like this one. So this is the methane that we have. And suppose we are reacting it with that is chlorine molecule, so therefore it could be written as in this way, and that too in presence of a particular we could say condition, and in this case we could either heat it or we could give, that is, UV light. So in this process, that is homolytic fusion of the that is chlorine molecule will takes place in this case, and that's the reason that we could see that the chlorine, one of the chlorine atom, it will replace the hydrogen, one of the hydrogen atom of the methane, and that's the reason that we could get the product, that is, here we could see that the chlorine atom has been replaced, plus this hydrogen that has been removed, because the chlorine atom that has been substituted or that has been replaced this hydrogen atom. Now that hydrogen atom would be removed and it will join with that of the chlorine atom, and hence it has been forming HCl. So in this case basically the product that we have got is methyl chloride. So talking about, we were talking about the substitution reaction. So this is a kind of reaction that could be called as a substitution reaction. The reason behind that is, as you could see, that one of the atom was been replaced by, or was been substituted by another atom, and that was of the reactant. So therefore these two reactants have reacted with each other so as to form a substitution reaction, as we could see. So now this group, that is this Cl atom that has been replaced one hydrogen atom of the substrate, that is the methane. Now this atom or the group of atoms also, it is an example where I have replaced an atom with an atom, but there are possibility that a group can also replace an atom. So that's the reason that this kind of atom which has replaced this hydrogen atom can now be called as substituent. So therefore this is the substituent, and the whole product is known as substituent product, and or substituted product, and that is the reason that we are learning about the substitution reaction, and that plays a vital role. And we have to also consider the conditions in which the reaction has been occurring. So this was one of the type of the substitution reaction, and now let us move on to the next one. So now let us start with the another one, that is let us talk about the second type of reaction, and that is addition reaction. So what is actually addition reaction? So let us learn about that. So a reaction in which two molecules combine to form a single molecule of product is called as an addition reaction. So let me give an example, and we'll go to the more detail about how and where do the addition reaction takes place. So let us give an example in this case. Suppose this is an alkene that we have taken, and that is basically known as ethene, and if we have reacted with a molecule like that of Br2. So what will happen is, because the alkene consists of a sigma bond and pi bond, then obviously we will get to know that the pi bond is the one which is very weaker bond, and that is the reason it will break. And that is what we could see, that the both the bromine atoms that are basically electronegative, and they will attack on this carbon atoms, each of the carbon atoms, and that is what we could get the product as. So if we consider the definition of the addition reaction, in that we have got to know that is the two molecules combine to form a single molecule product, and that is the reason that we are getting the two molecules that were been acting like a reactant, and or they are reactants, they are forming a single product. So therefore this reaction will have a particular condition, so that is what we have to maintain here also. So this is the particular condition that we have to maintain, and here we have saw that the two molecules are been combining to form a single product, and that's the reason you cannot find any kind of byproduct. But meanwhile, in case of the substitution reaction that we have did earlier, the number of product was been equal to the number of the reactants that was been used, and but in case of elimination reaction it is not that necessary, and that's the reason that we could see that the number of product is less compared to that of the number of reactants. So this is what addition reaction means. So if you observe that this kind of addition reactions are being shown by, that is, alkene and alkynes, so that is the reason that we could see this kind of reactions, and this kind of reactions are basically known as addition reactions. And talking about the one which are showcased by the alkanes are the one which are usually showing, because we are talking about organic reactions, because alkanes are the one that usually show substitution reaction, and they can show elimination reaction also. But when it comes to the alkene and alkyne, they usually have the tendency to show addition reaction, and this is what I meant. So talking about the name of the reactants that are being involved in this case, let me give you an idea. That is, the name of this is ethene, while this is the bromine molecule, while this one could be given as the IUPAC name also, and that is what we have did in our earlier lecture. That is, it could be called as, I would have given the carbon number 1 and this is carbon number 2, so therefore the name of this is 1,2 dibromo, and the total number of carbon that are being present in here is basically 2, so making this to be called as 1,2 dibromo ethane. So this was an example where we have discussed about what is actually addition reaction. So now let us move on to the another one. That is, we are going to talk about the third type of reaction that we have included in this overall topic, and it is elimination reaction. So what is actually elimination reaction? Let us talk about it. So talking about the definition of it, that it means that a reaction in which one molecule splits into two fragments molecules is called as elimination reaction. So that is the reason that it is basically the inverse of that we could say for an addition reaction. Because in addition reaction, what it was used to happen, that because two of the molecules, they would combine with each other so as to form a single product. But now it is totally opposite of it. Now one molecule is now being splitting into two different molecules, or two smaller molecules, and that is basically the elimination reaction. So now let me explain you with the help of an example, and it would be very much easy for us to understand, or to make a difference, that what is actually elimination reaction and what is addition reaction. So let us talk about that one. Suppose if we are talking about the elimination reaction, and like this one, that is suppose this is the reactant that we have, and we are reacting it with that of that is potassium hydroxide, but the total number of the products that would obtain would be more than 2, because here, as we could see, that the total number of reactant is basically 2, but now the product would be obtained as 3. But how? In this case, the alcoholic KOH has been used. So now it is not the aqueous one, because the both will have the different property. That means alcoholic KOH or potassium hydroxide will have different property compared to that of the aqueous KOH. So aqueous KOH and alcoholic KOH, they both react in different manner. And as we could see, that because of alcoholic KOH has been used, and the condition has been maintained that we have to heat it. So obviously the K will react with B, or the potassium will take out the bromine in such a manner that the KBr will be moved out as a byproduct. And meanwhile, this OH will take one of the hydrogen of the alpha one, and this OH will take out the hydrogen of this one. That is, if this is the alpha one that we are considering, then this one would be, suppose, the beta one. So now that's the reason that we could see that one of the hydrogen from the beta carbon atom would be removed, and in the form of, that is, H2O. So therefore this is OH that will remove one hydrogen from there. So now this is the H2O that has been obtained. And now we could see the thing that has been left out is basically CH2 single bond CH2. But so as to maintain the valency, there is a presence of a double bond over here. So these are the product that we could get. So now as you could see that basically alcoholic KOH has been acting like a that is a reagent, and that's the reason that we could see that one molecule now has been separated or is been splitted into two products, and that is the reason that or more than two products as we could see over here. So that is the reason that we could see that these two reactants are being involved, and we are getting three that is byproducts. And talking about the next one, that we could say that is it is opposite of that of the addition reaction, because as you could see that if this reaction gets if I reverse this reaction, means I could convert basically the alkene to back to an alkyl halide by using a suitable reagent, that is HBr, and that is the reason that we could get that is CH3 CH2Br. So they are opposite to each other, and so this is a kind of elimination reaction that I was talking about. So they are usually showcased by basically the saturated hydrocarbon, that is like alkane, but a different conditions are being required for this to happen. And that's it I wanted to explain. And moreover, we could also do this kind of, or we can also see this kind of that is reaction, or we could say elimination reaction, when we do a reaction in presence of excess amount of heat, and we could get the same product as you could see over here. So, and that's it I want to talk about the elimination reaction. And now let us move on to the next step, rearrangement reaction. So what is actually rearrangement reaction? Let us learn about this with the help of the definition that has been given to us. So it says that a reaction in which either the carbon skeleton or the functional group or both are modified is known as rearrangement reaction. So I will help you out to understand that how can we say whether the reaction is undergoing a rearrangement reaction, because there are several types of the reaction that we have talked about. So let me give an example. Suppose if we have a reactant like this one, is if I would explain. So this is the reactant that we have, and this is the reactant that is undergoing that is rearrangement. So for that we should understand that we should give a proper condition to that one. So therefore we are giving it a heat of suppose 473 Kelvin. But there is a rearrangement reaction that would take place, means the carbon either the functional group of the reactant would change or modified, as we could say, or the carbon skeleton would get modified. So there are some reactions where both of them get modified or only one of them get modified, and still that would be called as basically the rearrangement reaction. So this is the reactant that I have included, and if I treat it with a particular condition like this one, as if I have mentioned over here, so therefore we could see that the hydrogen which is adjacent to this carbon atom, as you could see over here, because this is the functional group that has been attached to this carbon atom, and this is the hydrogen atom that has been attached to the another carbon atom that has been attached to the carbon atom adjacent to that. And we could see that after the process or after the rearrangement, we could see that this whole has been substituted over here, and the hydrogen has been moved on to this oxygen atom. So that is the reason that we could get the product like this one. But it has a possibility to come back to again the reactant from which it has been evolved. So now the thing is, it is very similar to that of a substitution reaction, but the substitution reaction takes place with the other molecule, and because it needs a basically a substrate and a reagent. But here in this case, as you could see, that only one molecule was being needed so as to modify it. So somewhere we could say that this is a kind of special kind of substitution reaction where I'm talking about just this reaction. That is, it is a kind of substitution reaction where we could see that the substitution takes place within the molecule. So that is the reason it has been called to be that is rearrangement reaction. And talking about the name of this one, that is the name of the reactant that has been I have mentioned over here. So therefore the name of this one will be allyl phenyl ether, while that of that is this product that we have got, and we have got a product which is nothing but a phenol one, so therefore we could call it as allyl phenol. So this is the kind of product that we could get. So it was a kind of an example for the rearrangement reaction. And now let us move on to the next one that we have, and that is the last one that we are going to talk about, and that is condensation reaction. So let us talk about it. So now let us understand what is condensation reaction. So let us understand the definition of it first. So therefore it says that the reaction in which two or more molecules of the same or different reactants combine to form a product with or without elimination of a simple molecules like H2O, HCl, NH3, etc. is called as condensation reaction. So somewhere we could find it that the reactants are reacting with each other so as to remove a particular product, and and that product will be a smaller one, and that would be called as a condensation reaction. So let me help you out with an example. If I mention over here, suppose if we have mentioned that is an aldehyde like this one. So this is an aldehyde that we have took, and that is basically in terms of in common name, it is known as acetaldehyde, and the name according to the IUPAC name, it would be basically because two carbon atoms are being involved in this case, so therefore the name of this would be ethanol. So suppose if this is the reactant that has been reacting with the other molecule, and in this case suppose the other molecule would be an hydroxylamine like that of that is this NH2 and OH. So in this case we will get to know that is this H2 which is belonging to the hydroxylamine that will react with this oxygen, or the, so this H2 will be able to remove this oxygen of the ethanol, or we could call this as acetaldehyde, and we could see that there is a formation of a smaller byproduct that is basically H2O. And the rest of the thing that has been remaining is, now in this case the double bond is remaining as it is, so that is the reason we could see CH3 CH double bond NOH. So this is what we have got, and this is a kind of reaction that where we could call it as a kind of that is a condensation reaction. So we can't call this reaction as basically substitution reaction. The reason behind that is in substitution reaction one atom is being replaced by a group of atom, and in this case this happens, but this atom is being removed by the removal of this two hydrogen atom, as you could see over here. So that is the reason that it is a kind of a condensation reaction, and that is the reason that we could find over here as carbon-carbon double bond is also sustained in this case. So that is what I wanted to share with you, and talking about the product of that has been formed, and the name of the product is basically acetaldoxime. So that is the product that we have got, and because of and we could also make a condition in that case. So therefore this was an example of the condensation reaction. So now totally we have discussed about every kind of the possibility, or sorry, every kind of the type of reaction that occur in organic reaction. That's it I want to talk about. So thank you friends for watching this video. I hope you have liked this video, and you have got to various information regarding this one, and I hope you will share this video with friends, and yes, don't forget to subscribe Ekeeda channel. Thank you so much.